Okay, so looking at this bell work, you guys, this bell work is going to lead into the lesson we're doing today. So Kayla uh, used the formula a sub n equals a sub 1 times r to the n minus 1. Did anybody verify this right here?
Yes.
3 times 1.5 to the 19th, is that right?
Yeah.
Do we agree with that now? Now, Zach, you were saying that you...
It's right. The way we did it.
The wrong way. How
Yeah.
did you do that? Zach, I tried it and I got like a totally different number. We just used this.
Well, Zach was using this, and he put in his calculator and was looking at the window. And the reason that works is because if you look at the top number on this series, it's 3, then 9, then 27, then 81, right? So 3 to the 1 power is 3, 3 to the second power is 9, 3 to the third power is 27, 3 to the fourth power is 81. So 3 to the x power is the correct equation right there, yes?
But when I did that and divided it in terms, I only got 64.6.
It's because we did the 20th term, but it starts on 0.
Did you do the 20th term? Or does this start on 0? Or did you guys start on 0? Go ahead.
Oh.
Here, I'll show you.
Say that again. Oh, 2x minus 1. Yeah. Good point. Because that makes sense. Because if it was 2 to the 1, it would be 2, and our first term would be 3 halves, wouldn't it?
Yeah,
So
the first term, 0 is 1x is 0. So you just went to the 19. X is 19.
So when you went to x is 19. Okay. And you notice in the formula, what does it do? The 19th power, doesn't it? Right? So, yeah, that's kind of cool. So if you put that in your calculator, you can get that. Hey, it's pretty good you guys come up with that stuff. Okay? I like that. Now, do you guys remember? Raise your hand. I need to know this. How many of you remember working? I'm not asking you if you know how to do it all still. I'm just asking, how do you remember doing geometric sequences when you were in Math 1? I just need to know if you really learned it. Did you learn it? Okay, so you guys did simple ones, not hard ones. Okay. But, I mean, if you think about this one right here, you guys found, how did you guys find the common ratio? A lot of you guys did it. Yeah, found the top one and then the bottom one. Okay, Carly, is that what you did? Do you have another question? Okay. Trayson, what did you say? It was easy finding it. And so it's the same idea. Now, you guys, the second part of this, did you learn to find the sum of the first 20 terms of a sequence? Now, I saw some of you guys have the formula. What formula were you using? What was it? A1 minus something, isn't it? A1 minus r to the n minus... I just want to make sure you guys are using the right formula. Well, I don't know how your book wrote it, but yeah, it would be. I mean, you could write it. There's a couple different ways you could write it, but yeah, that's one way to write it. Okay, how many of you guys had that? Another way to write it that you see a lot is if they distribute the a sub 1 through, they have a sub 1 minus a sub 1 r to the n over 1 minus r. How many of you guys had it written that way? Which way was it written in the book? Both ways? Okay.
Which one's better? Easier. The bottom faster.
I kind of like the bottom one better myself, but the top one's fine too. Okay, now, how many did you guys put this in your calculator and get it? Okay. What did you guys come up with the answer? 19945.54. So 19,945.54. That makes sense for what we're doing right here. Okay. Yes.
What is like how do you find what the R and the N is?
Good question. How do you find the R and the N and all that?
Okay,
Well, what does A sub 1 stand for, everybody? Okay, I want everybody in your notes to write this down. A sub 1 is first term, right? Whenever you're working with sequences and series, A sub 1 always means first term. Okay? What does R stand for? What is R, you guys? It's called the common ratio. Yeah. It's the common ratio. It's the number that you're timesing the previous term by to get the next term. So what was our common ratio in this one? 3 over 2. If we times 3 by 3 over 2, we got 9 over 2. Then we times 9 over 2 by 3 over 2, we got 27 over 4. Then we times 81 over 8 by 3 over 2. I mean, we times 27 over 4 by 3 over 2 and get 81 over 8, and so forth. And we can continue that pattern. But you always got to find out, what is it being times by to get it? By the way, what makes a geometric sequence a geometric sequence? Write this question down. What makes a geometric sequence a geometric sequence? What makes a geometric sequence a geometric sequence? They have a common ratio. That's the answer right there. They have a common ratio. I would write that down. A geometric sequence has a common ratio. That's the definition of a geometric sequence. A sequence in which you have a common ratio. Okay? Did everybody get that down? Alex, listen, you guys get that down? What makes a geometric sequence a geometric sequence? Cameron, give the answer. You can ask her. Okay? All right, now, what other things do we need to know besides A sub 1 and R? What about N? What is N? The term number we're looking for, right? The term number. So in this problem right here, we wanted to find the 20th term, right? So N was 20. Okay, what does S sub N stand for? Yeah, the sum of the first N terms, right? Okay, S sub N means the sum of the first N terms. So if I want to find the sum of the first 20 terms, I write S sub 20. That means find the sum of the first 20 terms. I wrote it in English right here, find the sum of the first 20 terms, but I could have just wrote find S sub N. And you would have been saying that. I would say the first, yeah, I could have said find S sub 20, I meant, sorry. Find S sub 20, and that would have meant find the sum of the first 20 terms. Okay? Now, I had to give you guys this background because today's lesson, if you've seen the objective written over here, you will be able to derive the formula for a finite geometric series. Okay, a finite. What does a finite mean? It has a boundary. Okay? Look at this problem right here. Find the sum of the first 20 terms. What's my boundary? 20. I want you to find the sum of the first 20 terms. That's a finite number. An infinite number goes on forever, or a finite number stops. And so when I say find, you will be able to derive the formula for a finite geometric series. What's a series? It's when you find the sum of a sequence of numbers. So everybody write this down. A series, when you find the sum of a sequence. So a series is just adding the terms of a sequence together. of you guys have ever seen mortgage payment paper that shows the mortgage payments you're going to make? If you get a 30-year loan, it's going to show you the mortgage payments you're going to make every month for 30 years. It's called an amortization schedule. How many of you have seen one of those before? Okay. If you ever buy a house, which probably most of you will someday, you will see an amortization schedule. They will hand you one. Okay. And it will show you all the payments you have to make throughout your life. If you ever invest money into a savings, let me finish. If you ever invest money into an account of some type, and you have a fixed rate, then you can do the same thing. You can make a schedule of how much you're going to have in your account over time. So you can figure out how much money you're going to have after 30 years, let's say, if you're doing a retirement account. Do you guys understand that? So, an amortization schedule, you guys, is nothing other than finding the sum of a series. It's finding the sum of a series. And that's what it does. Okay? So what we're going to do today is that formula that we just wrote down. S sub n equals a sub 1 minus a sub 1 r to the n over 1 minus r. Did I write that down right? We are going to derive this formula. What does it mean to derive? What does that mean to derive? To what? Yeah, we're going to come up with we're going to find out how they came up with this formula. Because so when you guys someday when you guys buy a house, you know how they're figuring this out. Now, they're going to give it to you. They're going to give it to you, but smart people know how to interpret it, right? You want to know if they're giving it to you right. Do people sometimes cheat people in finance world? Yeah. If you don't know what you're looking for, they could cheat you. But usually nowadays with a big bank, that's not going to happen. But if you ever borrow money, personally, you want to check to see if they did the math right. So you can check it, and you know what's going on with the formula. Now, obviously, there's formulas that you can put these in, and you can figure this out. But it's nice to understand this a little bit, how it came about. Okay. So that's our next objective that I'm supposed to teach you is how to derive this formula. So we're going to do that in just a second. Okay, so we're going to go back and look at the homework. Someone wants to look at number 8, 3w squared minus 5w minus 2. Okay, before we go on with the lesson, 3w squared minus 5w minus 2, and we want to factor this and put it in a different form. Remember last time you were here, we learned how to we put things in different forms to show them. So 3w squared minus 5w minus 2 is what we're working on right here. How many of you guys don't remember how to factor these? There's a couple different methods. This is the one I like to use. First thing I do is I find the factors of 3. What are they? 3, 1. Okay, 1 times 3. Find the factors of this number right here. What are they? Well, think of it as a negative 2. Negative 1 times 2 or 1 times negative 2, right? We've got to decide which one are we going to use. You guys with us? Trevor, you asked me a question. Okay. So, if we times 1 times 1, and negative 2 times 3, that's going to give us negative 6 and positive 1. If you add those up, you get negative 5, which is our middle term. That's what we want, right?
Yeah.
So, all right.
Okay, this is where I'm confused.
Okay, look right here. One of these is going to be 3w, and one of them is going to be w, right? Because 3w times w is 3w squared. And I know at the end.
Oh, so you're going to times the opposite.
Yeah, well, I know that.
B times by 1.
Well, notice I'm timesing 3 and negative 2 together, right?
So then it'd be
The way we have it right here, 3 and negative 2. So I've got to put negative 2 in here. Would I put negative 2 right here?
no, because you already did it.
If I distribute, I'm going to distribute 3w and times it by those two. I'd never times it if it was right there, right? So I'm going to put it over here. and then the positive 1 right here. Okay? Do you understand how I decide if we're going to use 1 and negative 2 and 1 and 3? Well, I'm timesing 3 by negative 2, right? Okay, if I put negative 2, if I put this as 3w minus 2, am I ever going to times the 3w by the 2? No, I have to put it in the other thing to do that. Okay, the other factor. Okay, yes, Haley? Yeah. Okay, we're going to do number 9. Okay, we have g squared plus 8/3 g plus 16/9. Now, I've got to look for the factors of 16/9. Yes, Trevor. Okay, so I'm going to look for the numbers I can times together and get 16/9. What numbers can I times together and get 16/9? I could go 4 over 3 times 4 over 3, right? Well, look at this. 4 over 3 times 4 over 3 is 16/9, right? And 4 over 3 plus 4 over 3 is equal to what? 8/3, which is my middle term, right? So that one works out. So my factor is going to be g plus 8/3 times, plus 4/3, sorry. 4/3 times g plus 4/3. I'm looking for the two numbers I can time together and get 16/9, so that when I add them together, I get 8/3, the middle term. Does that help you out? 2/3 would be 1/3. That would be negative 1/3, negative 1/3. Okay. Okay, that's it with the homework. Yeah. I would suggest you really study this and make sure you know how to do this because it will be on the next test. How to derive formula for the finite geometric series. Okay, now I've given you right here an example of a geometric sequence. Okay, and we're going to kind of use this to help model what we're doing a little bit right here. But let's go ahead and figure out what R is. Okay, you agree with 2? Okay, yeah, because we're timesing the term by 2 to get the next term, right? So R equals 2. Okay, so what would the next term be? The next term would be 96, right? Okay, so the next term would be 96. So what is a sub 1 in this case right here? A sub 1 means the first term, which is, okay, 3. Now, these are the kind you said that you did when you were in 9th grade, right? And you worked with them. Okay, so what we're going to do is we're going to take, and there's a little formula that says if you want to find if you want to find the next term in a sequence, okay, you are just going to go, you're going to have a sub 1, right? And then, so if you take a sub 1 and times it by r, that's going to give you the first term, right? That's going to give you the second term, isn't it? If a sub 1 is the first term, the second term can be gotten by taking a sub 1 timesing it by r. How can the third term be? How can you get the third term? A sub 1 times what? Times r, right? How are you going to get the next term? A sub 1 times r times r times r. Now, what's the short way of writing r times r? Or r times r times r? R cubed. So we could write a sub 1, and then a sub 1 times r, a sub 1 times r squared, a sub 1 r to the third, a sub 1 r to the fourth, right? We could continue doing that. Now, if we counted this as the first term, second term, third term, fourth term, fifth term, and so on like that, you will notice that the number of r's is always what? One less than the term number, right? Okay? It's one less than term number. For example, right here, the fifth term, the number of r's in there is 4, which is one less than 5. Okay, now, we are going to give you a formula right here. Let's say I was to take, let's say we want to find, first of all, let's say we want to find the sum of the first 10 terms of this one. Now, we could list out all the terms, 3 plus 6 plus 12 plus 24 plus 48. 1, 2, 3, 4, 5. That's 5 terms, right? 96. What's the next one? 192. That's 7 terms.
384.
Is it 384? Yep, 384. What's the next one?
760.
Would be 700 and what? 768. And what's the last one? What is it? 12, 7, 7, 1400, 1500. 1500 and 36? Yeah. 1536. And I could add all those up and I could get it, right? But what if all of a sudden I said, find the sum of the first 20 terms? Or the sum of the first 100 terms? Okay, that would suck if you had to do it this way, wouldn't it? Okay? But that's why we have the formula. Now, the formula that we learned is that S sub n equals a sub 1 minus a sub 1 r to the nth over 1 minus r. And so I'm going to teach you how to derive this right now. Okay? I'm debating on whether I should do it with real numbers or with just the formula numbers. I think we're going to do it with the formula numbers because it's a little bit cleaner. Okay, S sub n equals a sub 1 plus a sub 1 r to the r plus a sub 1 to the r to r squared plus a sub 1 r to the third plus a sub 1 r to the fourth plus dot 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 a sub 1 r to the nth power. How many of you guys think you understand what that's doing right there? We just talked about it. What does a sub 1 stand for? First term. Now, how do you get the next term in a sequence, a geometric sequence? You times it by the common ratio. So the second term would be the first term times the common ratio. How do I get the third term? Okay, I got to times it by another r, which now there's 2 r's, right? A sub 1 r squared. And then another r, a sub 1 r to the third. And then another r, a sub 1 r to the fourth. And then 1 r to the nth power, right? Whatever n is. If it was 10 and so forth, right? We would do that. Okay? Now, that would take a long time. And so what they do to get this is they come up with a method. You can remember on an equation, whatever you do to one side, you can do to the other. Okay, now what they are going to do is they are going to times both sides of this equation by r. So we're going to times both sides of this equation by r. So we are going to have r times s sub n on this side. And what are we going to have over here? A sub 1 times r. What's the next term going to be? A sub 1 times what? What's the next term going to be? Squared, right? Plus a sub 1 r cubed plus a sub 1 r to the fourth plus a sub 1 r to the fifth dot 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 a sub 1 r to the n. What? Is it to the n? Minus 1. Because if we times, n plus 1, wouldn't it be? Because didn't we have an extra r on the end of each one of these? All we did is times both sides by r. So I times, and over on the right side, I have to distribute. I have to times every term by r. So all it did is raised r one more time. So instead of having a sub 1 on this first one up here, we have now a sub 1 times r. And then a sub 1 r squared. We added one more r we're multiplying it. Because we're multiplying both sides of this equation by r because it's going to help us derive the formula. Okay? I would have never thought of this, by the way. Well, because we have an extra r on each one, don't we?
Instead of A1, it's A.
Yeah, instead the first term, instead of a1, it's a sub 1 times r. I'm timesing r by both sides. Okay, times r by both sides. Times r by both sides. And all it's going to do is going to add an extra r on each side, right? Now. Oh, wait, you know what? This one right here, you guys, I forget. I'm not, on the very first term, I should put an n minus 1 right here. Why? Remember what we decided when we wrote this term out the last time? The first term, does it have an r? The second term has one r. The third term has two r's. There's always one less r than the term number, right?
Would that mean that instead of plus 1, it would just be n?
Yes, exactly. That's why I knew I was doing something wrong. So right here, this would just be a sub 1 r to the nth, because I forgot about that was a sub 1 r to the n minus 1, right? Now, here's a weird thing, deriving this formula. What they're going to do is we're going to take and we're going to subtract the second equation from the first equation. You know how when you guys solve systems of equations by elimination, you add two equations together? So is that legal? Can we do that? Yeah, we can do that. We can add two equations together. So we're going to add these two equations together. We're going to subtract them, actually. We're going to take the top equation and subtract the bottom equation. So S sub n minus r times S sub n, right? But on this other side, I'm going to take a sub 1. And think about this. You guys watch. I want to show you this. If I'm subtracting the second equation, notice that this thing right here, a sub 1 minus r, if I subtract this a sub 1 times r, they cancel out, right?
All the rest cancel out except for A sub 1.
These cancel out. These cancel out. These cancel out. A sub 5s are going to cancel out, right? And clear up until this one's going to cancel out, right? Because you're going to have an a sub 1 r to the nth, right? And so what are we going to end up with?
Because all you're going to end up with is...
Oh, I'm sorry. The a sub 1 minus r to the nth is not going to cancel. It's going to be this one up here that cancels out. I wrote that wrong. Because n is one more than that, right? A sub 1 r to the n. Okay? So the ones on top, we're canceling ones on the bottom. So what am I left with on the right side of this equation, you guys? Yeah, a sub 1 plus, well, actually I was subtracting right there, right? I'm subtracting the bottom equation from the top equation, so I'm minusing an a sub 1 r to the n. Now, is this starting to look like our formula? What we did is we subtracted the bottom formula from the top formula. Now, on this one right here, notice on the left side of this equation right here that we have left, what's common on both sides of this equation? S sub n to both terms. So if I factor in an S sub n, I'm going to end up with what? Look at this right here, you guys. If I factor an S sub n out of there, what am I going to end up with? Well, what if I factor out an S sub n, I'm left with what? 1 minus r, right? Because if I factor an S sub n out of S sub n, I'm left with 1. And then S sub n out of the r times S sub n, I'm left with an r. So I have a sub 1 minus a sub 1 r to the n.
Wait, I didn't understand that factor.
It's just like factoring. If I had 2 plus 2 times x, if I factor a 2 out, what am I left with? 1 plus x, right?
Oh, okay.
Because 2 times 1 is 2, and 2 times x is 2x. So that's what it's like. And then I want to get s sub n by itself, right? So what do I do to both sides of this equation? Divide by 1 minus r. Those cancel out, and I get s sub n equals a sub 1 minus a sub 1 r to the n over 1 minus r. That right there, you guys, is the formula we want, isn't it? Now, would have I ever thought of something like this? No. Some mathematician a long time ago decided it was really hard to add all those, and really tedious to add up a lot of numbers, and so he decided he was going to try and find a formula, right?
So you're just showing us how it gets the word.
That's what it means to derive.
How
What it means to derive is to find out the formula, figure out the formula, prove it, show that it's true.
How would you start
Well, you guys, that's a good question. Did you guys hear what Trevor just asked? How would someone ever think of something like that? If you spend enough time doing something, you start finding out, kind of like, you start thinking about it enough that you find out secrets about it, and you start finding out little mysterious things about it. And I'm sure this didn't happen overnight. He didn't sit down one day and do this. He probably worked on this for days, maybe weeks, maybe months, maybe years before he came up with this formula, right? These kinds of things don't just happen. Mathematicians go over time. You guys, how many of you guys know Piano Guys? You watch Piano Guys videos, okay? Remember one of their videos right there? What does it say on it? This finding the secrets. What is it? How does it go?
Yeah.
Force your way into its secrets. It's the only way to.
How about we just play it? I don't remember this.
So
Like, I really don't remember.
maybe I will. I'll play it here in just a second. But I honestly think that is true statement, because you think about Thomas Edison. He invented the light bulb. How many times? How long did he work on that before he got it? Years. How many different ways did he come up with that the light bulb didn't work?
A lot.
A lot.
Ton.
He did it and did it and did it until he figured it. It's secrets. He goes, I don't like to think of it as failing 600 and something times. He says, I found 600 something ways that it doesn't work.
Yeah.
He just knew he was going to do it. He just had to find the thing that worked, and he kept on doing it. But I like that.
Yeah.
Okay? And I really think it's true with mathematics. If you think about it enough, you can get it. Okay? Okay, this is part of your lesson today, you guys. Right here, the first part of this, what it says. Ready? Where's my... I want to talk about that. See, don't only practice your art, but force your way into its secrets. For it, and knowledge can raise men to the divine. I think that's true about anything. Anybody who's ever invented something, discovered something, that's what they've done. They've done it enough that they understand it inside and out, and they really know it. Okay? So should we listen to the song? All right, a couple things. First of all, I don't have an assignment for you, but I want to remind you about the extra credit assignment. It's due on Tuesday. So you guys all showed you where it was online, so make sure you look right there if you want to do it. If you have any late assignments, turn them in on Tuesday, okay, that you want to get done. Okay, because that's the last time I'm accepting them. Yes.
You don't have to do with people on that website, right? Like,
You can do any mathematician, okay, as long as you know they're a legit mathematician, someone who discovers, invents math, things like that, considered a mathematician. Okay, and you guys, I just want to say this. You know that quote right at the first. I really think that's true. You guys, the brain's an amazing thing. You can learn anything, and if you guys will uh, spend enough time thinking about something, you'd be amazed what you can come up with. I find this a lot of times because I've learned to do math and I've learned to problem solve. I've learned that I can learn just about anything. I never, growing up, I never knew much about like how a motor on a vehicle operated. I hadn't done much with that my whole life. But I fix my vehicle all the time now because I buy the part and I figure it out. And sometimes I have no idea what I'm doing when I start off, okay? And I just ask enough questions. Sometimes I Google something, and I tear something apart, and it doesn't even look the same thing as what the guy was showing me on the Google thing, and I figure it out. And I figured that I've noticed that if I spend enough time thinking about it and doing it, I can figure it out, okay? And you can do that with just about anything. So you guys can learn this math if you spend enough time thinking about it. You can learn anything. Any goal you have in life, anything you want to learn about, if you want to become a doctor or whatever, you can learn it if you spend enough time thinking about it. And the more you learn about it, and the more you learn to problem solve, the easier it gets. And you gain confidence and you know you can do it. So deriving that formula today that we did, that's what that's about, is somebody figured that out by spending enough time thinking about it. And that formula right there is used in the finance world all the time to figure finances. Okay, do we need to know how to drive that formula? Not necessarily now, because we have computers and we have formulas that do it all for us. But it's nice to know the math behind it and what's happening, because it makes more sense of our world to us. Okay, so on Tuesday, last day of the quarter. Okay, we'll turn this in. Okay, if you need to get your grade up a notch, get in any late assignments and do that, and we'll be ready to go. Okay.